Okay, here we go. This is the last example we're going to do. And sketchbook. Okay, so here is, and by the way, this is very similar to problem on your homework, number 31. So if you need help on it and you didn't watch this video, I'm probably going to say no thank you, go watch the video. Okay, so integral of 2x cubed plus x squared minus 7 over 2x cubed, boom, cubed minus 7. I want to integrate this guy. Well, it looks like it could be a 1 over u du thing, but notice the numerator is to the same degree as the denominator. It's a polynomial to the third degree, x cubed, over a polynomial to the third degree, x cubed. So, well, that kind of sucks. So that's hard to get into the form of 1 over u du, because normally the numerator should be a smaller power of exponent, of a polynomial. But let's go through the Wayback Machine and let's remember something. 2 plus 5 over 7, this is some serious stuff here, is 2 over 7 plus 5 over 7, right? We discussed this before. You can break up the numerator as long as you keep the denominator constant. In fact, that's how we add fractions, right? And if we, let's get a really hard one. You ready? 2 plus 3 plus 2 over 7. Epic! So I can rewrite this as 2 plus 2 over 7 plus 3 over 7. I can split these. I can add in any order. That's one of those cumulative rule for addition. I never remember those. But you can add in any order. So I can move the 2 over here and do 2 plus 2 first, and then do 3 second, and then add those two fractions, and we'll get the same thing as we started here. Well, we can apply this trick over here. I see a 2x squared minus 7 and a 2x cubed minus 7 in the top. So I'm going to rewrite this as 2x cubed minus 7 over 2x cubed minus 7 plus x squared over 2x cubed minus 7. Is that legal? Absolutely, it's legal, because we're just breaking up the order in which we add, and we're adding them like fractions. And what's this thing? 2x cubed minus 7 over 2x cubed minus 7. That is 1. So now I see I have an x squared over an x cubed. This looks more like a 1 over u du kind of thing. But let's split this up into two integrals. X squared over 2x cubed minus 7. So here I'm going to let u equals 2x cubed minus 7. So then du would be 2 times 3 is 6x squared. Do we have a 6? No, we don't. But I can add a 6 as long as I take one away. So now this is, let's see, what's the integral of 1? 1 is the same as x to the 0. So x to the n plus 1 over n plus 1, this is just going to give me x. And we'll have an integration constant, but we'll lump it in with the integration constant from the second one. Doesn't matter. Okay, so 1/6. So here's my du on the top. Whoops. And then here's my u on the bottom. I have 1 over u du. So I can write this as natural log of u. And there's my integration constant. And then I'll plug in u, which was this thing. So 2x cubed minus 7. So there we go. So we ended up with this thing from that guy up there. So the hint is that the numerator is not smaller in polynomial power than the denominator. And that tells me somehow I got to break this up. And there's a section in the book that does long division to do it, and we're not going to do that. I think that's going to be tough for us on the time we have, so we're going to skip that, and we're just going to do one similar to this. So you want to keep track of this and remember this little trick. And I think, that's what I just did. So I think that's all we have for this chapter. So if you have any questions, be sure you come to office hours and we can work on them together. And we'll see you later. Bye-bye.